Hi students, as a part of electrochemistry, today I am going to explain you about the electrochemical cell. Now before going to explain you about the electrochemical cell, first and foremost I have to explain you about EMF, because there is a link between EMF and electrochemical cell. First let me explain the EMF. So EMF is nothing but electromotive force. Electromotive force. EMF is electromotive force. Electromotive force. Electromotive force. Now what is electromotive force? It is the potential difference arised by the sources of electrical energy which drives the electric current to pass through external circuit. So if I repeat this for 2 or 3 times also, you cannot remember what exactly is the EMF, that is electromotive force. But after explaining the functioning of the electrochemical cell, then it becomes very easy for you to say what exactly is the EMF. So that will be the beauty of the concept. You will come to know what exactly is the EMF. Now let us come back to our actual topic. So our actual topic is the electrochemical cell, and the electrochemical cell is also called as the galvanic cell or the voltaic cell. So now let us see what exactly is the electrochemical cell. The cell which makes use of spontaneous redox reaction and convert the chemical energy into electrical energy. That is nothing but electrochemical cell or galvanic cell or voltaic cell. Voltaic cell. So simply the cell which converts the chemical energy into electrical energy is called as electrochemical or galvanic or voltaic cell. Now let us discuss the electrochemical cell with an example. The most familiar example of the electrochemical cell is the Daniell cell. So first let us discuss how the Daniell cell can be constructed. So for the construction of the Daniell cell, we need 2 beakers. So LHS beaker and RHS beaker. And in the LHS beaker, that is left hand side beaker, we have to take the aqueous zinc sulfate solution, and on the RHS beaker we have to take aqueous copper sulfate solution. And in the beaker in which aqueous zinc sulfate solution has been taken, we have to dip the zinc rod, and in the aqueous sulfate solution we have to dip the copper rod. Now both should be connected externally, making use of the metallic wire to the potentiometer. So both are externally connected with the help of the metallic wire to the potentiometer, and the potentiometer is meant for detecting how much amount of EMF is going to be generated during the functioning of this particular Daniell cell. And internally both are connected with the help of the salt bridge. So this is how the Daniell cell can be constructed. Now let us see the purpose of each and every item which is a part of this particular Daniell cell. Aqueous zinc sulfate solution and aqueous copper sulfate solution are the electrolytes. Zinc rod and copper rod are the electrodes. And the purpose of the metallic wire is to connect these electrodes, that is zinc rod and copper rod, to the potentiometer in order to record the EMF. And the potentiometer is meant for recording the EMF which is being generated during the spontaneous redox reaction between the zinc and the copper electrode. Now what is the role of the salt bridge? I will explain you later. what is the role of the salt bridge, I will explain you later, right? So this is how the Daniell cell is being constructed, and the importance of each and every item which is a part of this particular Daniell cell. Right. Now, what is the role of salt bridge? I will explain later, students. Right. So now, whenever this setup is made, now as we are well versed with the previous video, that zinc is associated with the negative standard reduction potential value. Its value is zinc. Its value is minus 0.76 volt. What is this? E0. What is E0? E0 of the electrochemical series is the standard reduction potential value. And whereas the standard reduction potential value of the copper is plus 0.34 volt. So according to the electrochemical series, it is amply clear that among the zinc and copper electrode, as the zinc is associated with negative standard reduction potential value, zinc acts as anode and undergo oxidation. On the other hand, copper acts as cathode and undergo reduction. Now what happens? Now whenever this setup is made, the zinc rod starts to dissolve in the aqueous zinc sulfate solution. So whenever it is dissolving, then zinc produces Zn plus 2 ions and loses the 2 electrons. That is, at anode, zinc is undergoing the dissolution in the aqueous zinc sulfate solution, producing the Zn plus 2 ions, aqueous, and loses the 2 electrons. Now whatever the 2 electrons which have been lost by the zinc upon oxidation are pushed by the zinc rod into the external circuit. And the external circuit consists of the metallic wire. And via metallic wire, whatever the 2 electrons which have been lost by the zinc upon oxidation enters into the copper sulfate solution, where Cu plus 2 ions are present. Now, at cathode, what happens is Cu plus 2 ions which are present in the aqueous copper sulfate solution gains the 2 electrons which have been entered into its solution, because whatever the 2 electrons which have been lost by the zinc upon oxidation have entered into the copper sulfate solution comprised of Cu plus 2 ions via metallic wire and gets reduced to copper solid. And this reaction is spontaneous. That is, zinc undergoing dissolution and producing the Zn plus 2 ions and losing the 2 electrons. Whatever the 2 electrons which have been lost by the zinc upon oxidation are pushed by the zinc rod into the external circuit, and the entry of the electrons via external circuit into the solution where Cu plus 2 ions are present. Now gaining of those 2 electrons by the Cu plus 2 ions which are present in the aqueous copper sulfate solution, the whole process is spontaneous. So due to the spontaneous redox reaction between the zinc and the copper electrode, EMF is going to be produced. EMF is going to be produced in the potentiometer, students. EMF is going to be produced. What is EMF? EMF equals to E cathode minus E anode. EMF equals to E cathode. E cathode means electrode potential of the electrode acting as a cathode. What is that electrode which is acting as a cathode among the copper and the zinc? Copper. So its value is plus 0.34. So 0.34 minus of electrode potential of the electrode acting as anode. What is that electrode among the zinc and the copper which is acting as anode and undergoing oxidation? Zinc. So its value is minus 0.76 volt. So totally EMF value will be 1.1 volts. So 1.1 volt of EMF is being developed due to the spontaneous redox reaction between the zinc and copper rod, which have been dipped in the aqueous zinc sulfate solution and copper solution respectively, which are a part of the Daniell cell. Daniell cell. So 1.1 volt is being recorded in the potentiometer. I hope you understood this. So EMF. Now, already I have explained what is EMF at the beginning. It is the potential difference arised by the sources of electrical energy which drives the electric current to pass through external circuit. Now, there is no need to mug up or memorize this definition. So, do remember? So, whenever you are writing the definition for the EMF, just you have to remember the zinc and copper electrode. Zinc and copper electrode. Right? Potential difference between sources of electrical energy, zinc and copper electrode. Potential difference between these two. What are these two? These are the sources of electrical energy which are driving the external current to pass through, which are driving the electric current to pass through external circuit. Potential difference arises by the sources of electrical energy. What are those sources? Zinc and copper rod, which drives the electric current to pass through external circuit. Now, the electric current is passing through external circuit with the help of the potential difference between the zinc and the copper rod. So, this is how you have to remember the definition of EMF, but don't memorize. If the definition of EMF is being asked in the exam, then immediately you have to get the idea of the zinc and copper electrode, potential difference. Why potential difference? Because both are not similar. One is acting as anode and undergoing oxidation, other is acting as cathode and undergoing reduction. Potential difference between sources of electrical energy. These two electrodes are the sources of electrical energy which are driving the electric current to pass through external circuit. So this is how you have to remember. This is how you have to remember. So now, in order to get the overall reaction, already you know this, you have to combine the anodic with the cathodic reaction, and whatever the equivalent ions and equivalent electrons present on the opposite side of the arrow mark should be cancelled. So there is no chance for equivalent ions. But there is a chance of equivalent electrons because it is a combination of oxidation and reduction reaction. Now, in the oxidation reaction, the two electrons are on the right side of the arrow mark, whereas in the reduction reaction, the two electrons are on the left side of the arrow mark. So, two electrons which are there on right side of the arrow mark of the oxidation reaction, two electrons which are there on the left side of the arrow mark of the reduction reaction cancel. The remaining the leftover portion is whatever the whatever the content which is remained on the left side of the arrow mark, we have to write on the left side. That is, what is the content which is remained on the left side of the arrow mark? Zinc solid plus Cu plus 2 aqueous, giving rise to Zn plus 2 aqueous plus copper solid. So this is the content which is remain on the left side or right side of the arrow mark, Zn plus 2 plus copper solid. So this is the overall reaction. Overall reaction. I hope you got it. Now we have to discuss the two things. I hope you understood this. We have to discuss the two things. The one is generally what we know, anode is positive, cathode is negative. Generally, anode is positive, cathode is negative. But during the functioning of electrochemical cell, anode is negative, cathode is positive. Why it is, we have to discuss. Anode is negative, cathode is positive. But generally, it is reverse. It is reverse. And this is applicable to the battery as well. Why it is? Because do remember, students, that you should not remember the anode and cathode with respect to their sign. With respect to their sign. Because the anode can be positive or negative. Cathode can be positive or negative depending upon the environment, depending upon the circumstances in which the electrode is present. It doesn't mean that anode is always positive, cathode is always negative. It is totally different in the electrochemical cell. Anode is negative, cathode is positive. Why it is? So what is happening, students, is whenever the zinc rod is undergoing oxidation, then it is pushing the Zn plus 2 ions. It is pushing the Zn plus 2 ions. Zn plus 2 ions are coming out. Zn plus 2 ions are coming out. Zn plus 2 ions are coming out. At the same time, 2 electrons are coming out. Already we saw the reaction. 2 electrons are coming out. Coming out in a sense, 2 electrons are being released. In fact, 2 electrons are being released. 2 electrons are being released. Now, whatever the 2 electrons which have been released by the zinc upon oxidation along with the Zn plus 2 ions penetrate inside the zinc rod. Penetrates inside the zinc rod. That is, electrons are negatively charged particles, and these negatively charged particles are penetrating inside the zinc rod. So, it will get the negative charge. It is getting the negative charge, but it is undergoing the oxidation. And what we know, the electrode at which oxidation occurs is called anode. That's the reason it is anode. That's the reason it is anode. On the other hand, what is happening here? So, Cu plus 2 ions, SO4 minus 2 ions are there. Now, copper is releasing the sulfate ions out. SO4 minus 2 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 ions. SO4 ions minus 2 means what? Minus. That is, it is releasing the negatively charged particles out. Now, it is, if any of the substance is releasing the negatively charged particles, definitely that particular substance will become positive. It will become positive. But it is becoming positive. But here what is happening? Reduction is taking place, and what we know, the electrode at which reduction occurs is cathode. It is positive, but as it is acting as cathode and undergoing reduction, it is cathode. That is the reason negative in the case of the electrochemical cell, and positive in the case of electrochemical cell is anode and cathode respectively. You have to know the mechanisms. You have to enter into the detail. Why? So what you will do, just memorize. So if you write negative as negative for this and positive for this, you will get the marks. But what about the concept? You don't know the concept, right? So why it is negative in the electrochemical cell, why it is positive in the electrochemical cell, that is seen is reverse. So I hope you understood this. So only one thing is left on us, that is salt bridge. What is the role of the salt bridge? So salt bridge is a U-shaped glass tube. It is a U-shaped glass tube either comprised of ammonium nitrate, salt or potassium chloride salt. Let us say that this particular salt bridge comprise ammonium nitrate salt, and this ammonium nitrate salt are held together with the help of agar gel, that is NH4 plus. Ammonium nitrate means it comprises NH4 plus and NO3 minus, right? KCl means K plus and Cl minus. Now let us say that these ammonium ions and nitrate ions of this ammonium nitrate are held together with agar gel. So that is nothing but salt bridge. Salt bridge is a U-shaped glass tube comprised either the ammonium nitrate or potassium chloride, in which cations and anions are held together with the help of agar gel. Right. Now what is its function? Its function is to maintain the electrical neutrality. Maintains the electrical neutrality. What do you mean by electrical neutrality? So see what is happening. Whenever the zinc rod is continuously or spontaneously undergoing the oxidation reaction, it is producing the Zn+2 ions out. Right? Now the concentration of Zn+2 ions will increase abruptly, drastically it will increase. It will increase in such a manner that it will become the barrier for the free flow of the electrons. Becomes the Zn+2 ions will increase in such a manner that these Zn+2 ions will become the barrier for the free flow of electrons. If the electrons are not flown, then the whole process is not possible. So there is a traffic jam. On the other hand, what is happening in the CuSO4, copper is releasing the SO4 minus 2 ions out. SO4 minus 2 ions out, and the concentration of SO4 minus 2 ions increases abruptly or suddenly or drastically. So what is happening? On the LHS beaker, the concentration of Zn+2 ions is increasing, and in the RHS beaker, the concentration of sulfate ions is increasing. Now, these ions, which are a part of LHS and RHS, will become the barrier for free flow of electrons. There is a traffic jam. So in order to eradicate this traffic jam, what we need to do? There is a need to neutralize the excess amount of Zn+2 ions produced during the spontaneous oxidation of the zinc rod, and SO4 minus 2 ions during the spontaneous reduction reaction of the copper rod. So now what the salt bridge will do? So now the salt bridge comprises cations and anions. No. So what happens now? So NO3 minus ions because these are the cations. So cations can be nullified by anions. Now NO3 minus ions enter inside this beaker where Zn+2 ions are present and converts to zinc nitrate. Now whatever the excess amount of the Zn+2 ions which are behaving like the barrier for the free flow of electrons are neutralized by the nitrate ions, which are the anions of the salt bridge, which is a part of ammonium nitrate salt, which has been held together with the help of other gel. So in a similar fashion, in order to neutralize these sulfate ions, which became the barrier for the free flow of the electrons in the copper sulfate solution, which ions are present in the salt bridge, student? Ammonium ions are present. So NH4 ions, NH4 plus, NH4 plus, NH4 plus, all NH4 plus ions will penetrate inside the solution where the concentration of sulfate ions have been increased drastically, by which whatever the sulfate ions which behaved as the barrier for the free flow of electrons have been nullified. So now what exactly is the salt bridge is doing? It is maintaining the electrical neutrality. So without maintaining the electrical neutrality, the electrochemical cell functioning is not possible. This is the one which is responsible for the free flow of electrons from one solution to another solution. That is the reason, due to this spontaneous redox reaction between the zinc and the copper electrode, which are a part of the Daniell cell, is capable of converting the chemical energy into the EMF, that is electrical energy. I hope you understood, students. Thanks for watching.